So the translations. Remember, a translation is a slide. Okay? There's two ways to write a translation. This is the geometry way. Okay? So they start off with a coordinate, x, y. So this just means take the x and the y and move it. If it's written like this just means x minus 2 means left 2. Y plus 3 means up 3. Okay? So everyone understand how to read those?
Yes, sir.
So all of this stuff doesn't mean anything other than it's the way the notation is written. All you got to do is look at this to see what happens. A vector is like what airplanes use to fly. A vector starts in one place and ends in another in a straight line. Has anyone here ever seen Airplane, the movie?
No.
Oh, yeah.
No? It's an old movie. And when they're in the cockpit talking, the pilots, Kareem Abdul-Jabbar is one of the pilots. And does anyone know who he is?
Yeah.
Basketball. But anyway, one of the guys' name is Vector, and they go back and forth. He says, "What's your vector, Victor?" Yeah. Vector in Despicable Me, if you notice, he says, "I'm vector because I have direction and magnitude."
Oh.
Magnitude is the speed that it flies. Okay? So, a vector can be written like this. It's a lot easier to write the directions. It means the same thing. It's just the directions. How do you get from your starting point to your ending point? Instead of writing it like this, they just do this. Okay? So these two are the same exact directions. It's just this represents a vector. This is a translation, but they do the same thing. This is called vector notation. This is called coordinate notation. You do have to know how to do both ways. So on a vector, I think everyone knows what the initial point would be. That's where you start. The terminal point is where you end. Okay? Terminal, like an airport, where you wait. Okay, that's where they get it. So like if we did this vector, -2, 3, if you start here, -2 means I got to go left 2, and +3 means up 3. So when you draw the vector, you put an arrow where you end. Now a lot of times people do this. If it's this point and this point, they'll go like this. It doesn't keep going. The arrow stops on the point. Okay, so you have your initial point, your terminal point, the vector is just like that. Okay? Now a vector is very similar to, you notice we went left 2 and up 3. It's similar to slope. If you remember, slope is, what's different about slope? It's rise over run. A vector is x over y, which whenever they invented algebra slopes, they should have did it this way so it wouldn't be so confusing. Okay, so once again, a translation is an isometry, which means it doesn't change size or shape. Here they've got, remember in the assignment we did yesterday, where if you reflected something over 2 lines, if you flipped it from here to here, and then you flipped it from here to here, remember it's the same thing as a rotation. And how can you tell what the rotation is? How many degrees?
You double the degrees.
Yep, you just double this. So it'd be 140 degree clockwise rotation. This is similar for a translation. If you reflect something over, the difference here is the lines are parallel. Okay? Line K and line M are parallel. Here's the original, here's Q prime, P prime, and here's Q double prime, P double prime. If you reflect it, then reflect it again. It's the same thing as just doing one translation. You notice this is exactly the same as that?
Yeah.
Okay? So, here we've got a triangle, ABC. Here they wrote it in coordinate notation. Sketch this triangle after this translation. All we're worried about is those. This just means take each x and y and move them like this. So remember, what does x plus 4 mean?
Right.
Right 4, and what is y minus 5? Down 5. So you just do that to all 3 points. Right 4, down 5. So it's the easiest one to do. It's a lot easier in rotations and easier in reflections. Okay, now the points are also easier to find without actually doing the drawing. My new A prime is over 7 down 2. My new B prime is over 2 down 3. And my new C prime is over 5 up 0.
You said it's easier to.
Yeah, you don't really need to draw them to find, because all you got to do is, if you have the original coordinate, this means take the x and add 4 to it. 3 plus 4 is 7. Take the y and subtract 5. 3 minus 5 is negative 2. Yeah.
Why is it 4 and 5?
This is what they told us to move it.
Oh,
Right there, yep. So that's why you don't need to graph these unless they tell you to, in order to find the new points. Because B, I could have just looked at, take the x and add 4, and I'd get 2. Take the y and subtract 5, and I'd get negative 3. Understand how that works?
yes.
Okay. Now on some of the problems, I'll just make one up here. Okay, some of the problems today, they give you the image and they're wondering what is the original point. Here they gave us the original and we found the image. So if this is the directions and this is the image, what would you do to find the original point? You do the opposite. Instead of subtracting 2, you'd add 2. Instead of adding 1, you'd subtract 1. Okay? So you can just check it. If I took the original and subtracted 2, I'd end up here. If I took the original and added 1, I'd end up there. Okay? So again, you don't need to actually graph it to find the new coordinates. This says take the x and subtract 6 and take the y and add 3. A is left 3 down 1. So A prime is going to be negative 3 minus 6 is negative 9. And negative 1 plus 3 is 2. B is over 3 and up 4. So 3 take away 6 is negative 3. 4 plus 3 is 7. And C is over 4 down 2. So 4 minus 6 is negative 2. And negative 2 plus 3 is 1. Everyone got that? All right. Now we get to the vectors. To name a vector, on these 2 points here, everyone remember from what I told you before, what is the starting point, C or D?
C.
C, because the arrow's at D. So when you name the vector, you got to put them in order. The starting point first, where you end second, and the symbol for a vector is half a ray, like that. Okay, so you just put 1 barb on it. And the component form then, instead of writing it like this in coordinate notation, component form is the easy way. It's just, how do you get from the start to here? And remember, it's the opposite of slope. It's the way slope should have been. I go right, 1, 2, 3, 4, and I go up, 1, 2, 3. Okay, so that's how you name it. and write the component for them. So this one starts at P and ends at Q. So then you put the vector symbol. To get from P to Q, you go side to side first. So that's left, so it's -3. And then down 1, 2, 3, 4, so it's -4. Everyone got it? Now, sometimes you have a vector right there, vector AB. It does start at A, so you gotta put A first. So to start from A to get to B, remember you go side to side first, so I gotta go left, 1, 2, 3, 4. And then what do you do? 0, right. On these coordinate notations, if they ever wrote one like this, this means right 2, and then up 0, because there's nothing on there. So if it's just a Y or just an X, that means you don't do it. Okay, so here we've got this triangle EDF or EFD. They give us the component form is 3, 6, so we're going to use this vector JK to translate this. It's doing the same exact thing, it's just written this way instead of the other way. So all this means is move all the points right 3 and up 6. Okay? So right 3, up 6. So that would be F prime, E prime, and D prime. All right. So that should be easy enough, huh? All right.